Welcome to classwork 9.2. Today we're going to talk about the law of sines. So take a moment, pause the video, and just write down the law below. Then once you're done writing it down, unpause and continue. So what's really cool about this law is that it works on any triangle if given the right info. So for like Sohcahtoa, for example, that only works on right triangles. But law of sines can actually work on any kind of triangle as long as you have information like the ones we will have today. So let's get right into it. So for this whole chapter, you're going to need a calculator. So make sure you have your calculator ready. And notice how there are two versions of the law. Today we're going to focus on using this version right here, because this version is good for finding lengths. So right, good for finding lengths. And that's because notice how the lengths are on the top. So hopefully from geometry recall that lengths in triangles are often represented as lowercase, and the angles are often these uppercase. So these are your angles right there. So we'll focus on this first law today. Again, the other law is just the same exact thing, just flipped. So first thing we're going to do is just draw a generic triangle. So just doesn't really matter how you draw it. I'm just going to draw it generic. But in homework, you can draw it like that too. A, B, C. And it's important to note how it corresponds. It must be labeled like this respectively. Notice how angle A is directly across from side length A, B is directly across from B, and C is directly across from C. So that has to be the case, however you label your angle. So make sure you do that. Now let me get rid of that to make it a little easier to look at. Let's label. This is 40 degrees, B is 60 degrees, and A is 4. Okay, so let's start working. The goal is to figure out everything else. The first thing I want you to do is write this down. Really important. Big star. I want you to identify your, quote, pair. Now what I mean by pair is it's basically like an angle and side length partner. So for example, the pair here is right here. Notice how A, we have 40 and 4. That pair is the key to finding everything. So that's going to be our initial. We're going to write 4 over sine 40. And then this thing is going to be equal to, just pick a letter you want to find. Let's say you want to find C. C over sine C. Now you might be thinking, well, how do I find that? Because there are two variables. Well, look at your triangle. You can find C easily. This has to be 80 degrees, because in a triangle, it always adds to 180. So really, we can put 80 right there. Now to solve this, make sure you don't cross multiply. Simply multiply both sides by sine of 80. So now we get C is equal to 4 sine 80 over sine 40. And then you're going to punch that in your calculator, and you get C is equal to 6.13. And notice for lengths, we're going to round to the nearest hundredth. So I'll box that. .13. Make sure you fill it in your triangle. It makes it easier for me. And then all we gotta do is now find the other leg. So go back to your pair. 4 over sine 40. That has to equal B over sine B, which is 60. Same thing, multiply by sine 60. So B must equal 4 sine 60 over sine 40. Put that in your calculator, and you get 5.39. Box that. And again, notice how we're rounding to two places. That's what we'll do today. You're going to put 5.39 right there in your triangle. And I'll just highlight everything we found today. So look at that. There's your 80, 6.13, 5.39. So let's go on to example 2. We're going to start the same way. We're going to draw a generic triangle. And again, you can just make it any triangle. This is just generic, so this is clearly not to scale. A, B, C, A, B, and C. Label it. 35, B is 15, C is 5. Again, notice how we can find the last angle. Just add 35 and 15, that'd be 50, which means this must be 130. Now again, the first step, find your pair. Hopefully you can already tell the pair is going to be right here, your 30 and your 5. So you can just highlight that right there. So that's always where you're going to start. So I'll put a divider for you. Write your pair, 5 over sine 130. This should be equal to, now pick a letter you want to find. Let's say you want to find A. A over sine 35. Let's solve. Multiply both sides by sine 35. So A should equal 5 sine 35, all divided by sine of 130 degrees. So A must be 3.74. Let's throw that in, 3.74. Part 2, start with your pair. Oh, let's put that over here. 5 over sine 130. That's equal to B over sine B, which is 15. Solve for B, multiply by sine 15. So B should equal 5 sine 15 over sine 130. So B must equal 1.69. And again, you get these values by plugging them in your calculator. 1.69. Okay, so I'm just going to quickly highlight the answers we found. So there's your 130, there's your B, and there's your A. So there's your complete triangle. Last question. We're going to find the height of a mountain. So this will be a little complex. Let's go through it slow. It says to measure the height of a mountain, a surveyor takes 2 sightings of the peak at a distance 900 meters apart on a direct line to the mountain. Okay, so first let's just sketch this mountain. So I'll just do a sketch here. Okay, then there's a surveyor taking a sight. So let's just say there's a point here. So he's taking a sight to the top of the mountain, right there. And then notice how it says takes 2 sightings. They're 900 meters apart. So that would mean if we were to connect it here to here, there's a second dot right about here. We know this distance, that's 900. And then this is the second line of sight. So here's our triangle. Notice how it is a right triangle and it's pretty complex at this point. Let's keep reading. The first observation is 47 and the second is 35. So it's important to understand that the 47 must have been here because that's the bigger angle. The bigger angle has to be closer. So imagine you were like to walk. Imagine you like walk along this line. As you get closer to the actual mountain, the angle should increase. So it wouldn't make sense if you put 35 here and 47 here because the angle couldn't get smaller as you get closer to the mountain. So 47 must be there. So that's the first sighting. And the second sighting must have been him walking away. So this must be 35. Okay, the transit is 2 meters high. So the transit is like that tool. It's just like a measurement tool. Measurement tool. That just means at the end, we just have to account for this little bitty 2 right there. Okay, and the goal is to find the height of the mountain. So for now, let's just call this thing, yeah, we can call it h. We'll think about the end answer once we get there. Okay, so for now, let's just find that h. So notice how we have that 900. So previous to this law, we really couldn't solve this. It'd be pretty difficult. But now with what we know, we actually can solve this. Because if this is 47 degrees, sorry, right here, if this is 47, then this must be 133. Because it has to make 180. And then if that's 133, then this little thing must be 12 by the same logic, because it has to make 180. Okay, so from here, let's think about a couple things. Let's call this leg x. And notice how we actually have a pair. The pair is going to be right here. We have this 12 and this 900. And I can actually find this x I just put. So I'm going to find that. I'll do that on the side here. My pair is 900 over sine 12. That should equal x over sine 133. Now let's solve. Let's multiply by sine 133. So x should equal 900 sine 133 degrees over sine 12 degrees. So x should equal 3165.86. So right here we can fill this in. 3165.86. Now of course that's not the answer, we found x, but we can do a little trick now. Notice how this is a right triangle. So now let's just use Sohcahtoa. So let's imagine like you're standing right there. I can use sine. Sine of 35 is equal to h over 3165.86. Now let's multiply by 3165.86, and then your calculator, 3165.86 times sine 35. We calculate this, you get 1815.86. Now the tricky thing is this 2. So to account for that, simply add 2. So the answer is 1,817.86 meters. That's the height of the mountain.